Okay, good morning, everyone. I think we're going to get started here. My name is Becca Zombeck. I'm with the AGU Media Relations Office, and welcome to our press briefing, Climate Science 2021, the latest from the IPCC. We will begin with the panelists each giving brief presentations describing their work, and then we'll open it up to questions from reporters. We will end on the hour or when there are no more questions, whichever comes first. On-site reporters will be able to meet with on-site panelists in the quiet room in room R05, which is next to the press room on the second floor, following the press event. Reporters, this is a Zoom webinar, so you will not be able to turn on your video or microphone. So if you would like to ask a question, please type your full name and affiliation into the Q&A box, not the chat box, but the Q&A box. And my colleague Liza will request that you unmute yourself to ask your question. Alternatively, you can type your full question in addition to your name and affiliation, and we can pose the question on your behalf. And we will read or call on the questions in the order that they were received. You can write in your question at any time, but it will not be asked until the panelists have finished their presentations and we are in the Q&A period. Please do make sure that your Zoom name is accurate so that we can find you in the participant list. You may also raise your hand to help us find you faster, but only raising your hand isn't sufficient for asking a question. The slides and any additional materials from this briefing will be posted in the Press Information Exchange on AGU Connect, and we'll drop a link to that in the chat. The event is being recorded as well, and the recording will be posted to AGU's YouTube channel and also linked to in the Press Information Exchange on AGU Connect. Should any technical issues arise if Zoom webinar goes down for any reason, we will switch to carrying out this press event through a teleconference line. If that does occur, we will email everyone immediately with instructions how to gain access to that teleconference line, and we'll just continue in that format. I will now turn it over to Catherine, who will offer some context to this new report and kick it off by introducing the panelists.
Thanks, Becca. You can go on to the next slide. So, hi, everybody, and thank you for joining us today. My name is Catherine Leitzel, and I'm the Communications Manager for Working Group 1 of the IPCC. And I just wanted to start off by putting this report into some context. So you're probably aware that the report we're talking about today came out back in August 2021. And this is part of a whole IPCC assessment cycle. This is the 6th assessment cycle. It started out with 3 special reports, and we had our report on the physical science of climate change, which came out in August. And then there are 2 more reports from Working Group 2 and Working Group 3 on impacts, adaptation, and vulnerability, and then mitigation of climate change coming out this winter, spring, in February and March. And then the synthesis report scheduled for September 2022. Next slide, please. So for each of these upcoming reports, there will be a media advisory about a month in advance. So the dates I gave you are kind of tentative. And once those dates are finalized, there will be a media advisory that tells you everything about registration for embargoed materials, press conferences, etc. The best way to stay informed about this is to get on the IPCC's global media list. And you can do that by emailing this email address, which is at the bottom, ipccmedia@wmo.int. They also post everything on social media. Next slide, please. I also wanted to highlight some of the science sessions that are connected to what we're talking about today, especially today, just after this, about an hour later, starting at 12:45, there will be a huge session, 4 hours long, of scientists talking through the report chapter by chapter with lots of time for questions and answers. So if you haven't had enough climate science yet, please join us for that. There's a lot of other sessions going on, but I also wanted to call your attention to on Friday, there's a session on climate change in South America, and a couple of our authors are also presenting findings from the IPCC report there. I also want to just quickly note that our authors today who are on site, they may be rushing off to get to that science session. So if you don't catch who you want to talk to, please feel free to email me. And also in general, please feel free to email me or the IPCC media team if you are looking for climate change experts. And then finally, to come back to the 2021 climate report, our report that came out in August, this is really the most comprehensive view of what we know today about the physical science of climate change. It was written by 234 authors from 65 countries. Together, they assessed over 14,000 scientific publications, and the review process involved over 78,000 review comments, all of which are responded to and reviewed by the authors. And all of this will actually be published with the final draft of the report. So I'm really happy to have from those 234 authors our speakers today, Junyi, Vaishali, Alex, and Daniel. Junyi and Vaishali are going to lead off by sharing some of the key findings and some of the major science advances in the report. And then Alex and Daniel, since this is more this is the AGU, they're going to take us to the Americas. They're going to highlight some of the regional information in the report, which is a new thing for IPCC, and then highlight findings for the Americas for North, Central, and South America. And then we have some great panelists here as well for the Q&A session. So I'll hand it over to Junyi. Thanks, everybody.
Thanks, Catherine. Thanks to recent climate science advances, we now have the clearest picture of how human activities are affecting the Earth's climate at global and regional scales. The assessment of the current state of the climate combines insight from observations, paleoclimate archives, attribution studies, and studies of the Earth's energy budget. We show that recent changes in the climate are widespread, rapid, and intensifying, and unprecedented in thousands of years. Next, please. Global surface temperature in the last decade was 1.1 degrees Celsius higher than in 1850 to 1900, and the warming rate is unprecedented in the last 2,000 years. Each of the last 4 decades has been successively warmer than any decade that preceded it since 1850. Next, please. It is indisputable that human activities are causing changes in atmospheric composition and climate change. The evidence for human influence has grown since the previous Working Group 1 report published in 2013. Next, please. Human activities are causing an imbalance of the Earth's energy budget, which can be measured in terms of radiative forcing. Greenhouse gas emissions cause a positive radiative forcing, leading to a warming effect, while aerosol emissions cause a negative forcing, leading to a cooling effect. Observed warming is driven by emissions from human activities with greenhouse gas warming, partly masked by aerosol cooling. While natural variability, including natural factors and internal climate variability, does modulate human-driven changes at regional scales and decadal scales, it has a little effect on anthropogenic global warming at the centennial scale. Next, please. We have improved our understanding on the role of each individual component of human influence, including emissions of greenhouse gases, aerosols, and their precursors, land use changes, and aviation contrails. And as you can see from the figure, the main drivers of warming to date are emissions of carbon dioxide and methane. Next, please. Our assessment shows that unless there are immediate, rapid, and large-scale reductions in greenhouse gas emissions, limiting warming to 1.5 degrees Celsius will be beyond reach. Next, please. Global climate models and scenarios are the basis for climate projections in Working Group 1. Climate models used in this report have been improved as compared to the models considered in the previous report, including new and better representation of physical, chemical, and biological processes, in addition to higher resolution that better resolve those processes. The illustrative set of 5 scenarios used in this report comprise greenhouse gases, aerosols, and land use patterns. These scenarios span a broader range of greenhouse gas and air pollutant features than assessed in earlier Working Group report. The very low and low emissions scenario represent carbon dioxide emission pathways in which carbon dioxide emission decline to net zero around or after 2050. carbon dioxide emissions in the intermediate scenario keep the current level until 2050 and then decline. The high and very high emission scenario represent carbon dioxide emission pathways without any climate change mitigation. Next, please. For the first time in an IPCC report, we comprehensively assess future changes in global surface temperature, ocean warming, and sea level by combining multi-model projections with observations of historical warming, as well as improved understanding of climate physics and climate sensitivity. In other words, we understand better than ever how the climate system responds to the emissions of greenhouse gases. In all cases, our best estimate is that global surface temperature, when averaged over 20 years, will reach 1.5 degrees Celsius in the period 2021-2040. This implies that by 2030, every single year has a 50% chance of having an annual global surface temperature above 1.5 degrees Celsius. Next, please. For the intermediate scenario, our best estimate is that global surface temperature will reach 2 degrees Celsius in around 2050 and around 2.7 degrees Celsius by 2100. Global warming of 1.5 degrees Celsius and 2 degrees Celsius will be exceeded during the 21st century unless deep reductions in carbon dioxide and other greenhouse gas emissions occur in the coming decades. It is clear now more than ever that the future is in our hands. I now hand over to Vaishali.
Thank you, Jenny. So Jenny just showed you that future emissions cause future additional warming. Then the question is, what can we expect from every increment of warming? Many changes in the climate system will become larger in direct relation to increasing global warming as assessed in this report. Next, please. For example, additional warming is projected to further amplify permafrost thawing, loss of seasonal snow cover, and of Arctic sea ice. To give you an idea of the magnitude of change, the volume of perennially frozen soil within the upper 3 meters or 10 feet of the ground will decrease by about 25% per degree Celsius of global surface air temperature change. As shown in the top figure, the Arctic is likely to be practically sea ice free in September, at least once before 2050, under the 5 scenarios we considered, with more frequent occurrences for higher warming levels. Acidification of upper ocean, as shown here in the bottom plot, and loss of oxygen will continue to increase in the 21st century at rates dependent on the trajectory of future emissions. The slow components of the climate system will continue to adjust on timescales of hundreds to thousands of years. Next, please. And this means that some changes are irreversible on centuries to millennia, but can be slowed by limiting warming. Next, please. So for example, sea level is committed to rise for centuries to millennia due to continuing deep ocean warming and ice sheet melt, and will remain elevated for thousands of years. So focusing on this century, we see in this plot projections of sea level changes under the 5 emission scenarios examined in this report. By 2050, sea level is committed to rise by 15 to 30 centimeters or 0.5 to 1 feet above present day level, almost independently of emissions. And beyond 2050, sea level will continue to rise, but with a rate and magnitude strongly dependent on the trajectories of future greenhouse gas emissions. By lowering greenhouse gas emissions and limiting the level of future global warming, we also increase the chance of avoiding triggering irreversible ice sheet instabilities that could substantially increase sea level rise. The projected ranges that we show here only consider the processes that are best understood and are the likely range of sea level rise. The report acknowledges that there is deep uncertainty associated with specific processes related to the behavior of the Antarctic ice sheet. For high emissions and large warming levels, as shown in the dashed line, although it is low probability, we cannot rule out the possibility that rapid ice sheet loss could lead to more than 1.5 meters sea level rise by the end of this century. Next, please. By 2300, the low greenhouse gas emission scenarios would lead to a sea level rise of around 50 centimeters to 3 meters, that is 1.5 feet to 10 feet, while very high greenhouse gas emission scenarios could lead to 2 to 7 meters, about 7 to 23 feet of rise, and potentially many meters more when accounting for ice sheet instability processes. Next, please. So we've seen why every increment of warming matters. And so moving on, we now focus on the physical science perspective on limiting global warming. And here the report finds limiting human-induced global warming requires limiting cumulative CO2 emissions, reaching at least net zero CO2 emissions, along with strong reductions in other greenhouse gases. Additionally, the report finds that strong, rapid, and sustained reductions in methane emissions will limit the warming effect from declining aerosol pollution and improve air quality. Next, please. Our report confirms a close relationship between cumulative CO2 emissions and increasing global surface temperature. This is shown here for the 5 illustrative scenarios under 2050. The near linear relationship between cumulative CO2 emissions and maximum global surface temperature increase caused by CO2 implies that stabilizing human-induced global temperature increase at any level requires net anthropogenic CO2 emissions to become zero. Next, please. This report also stresses the important role of methane reductions in limiting warming and improving air quality. The figure shown here shows the difference between the intermediate, low, and very low emission scenarios in terms of air pollution levels and global surface temperature effects in the near term, that is 2040, and in the long term at 2100 relative to 2019. In the low and very low greenhouse gas emission scenarios, assumed reductions in anthropogenic aerosol emissions lead to a net warming, as shown by the purple bars, while reductions in methane and other ozone precursor emissions lead to a net cooling, shown in orange and green bars, while ozone and air pollution levels decline in both of these scenarios. And so because of the short lifetime of both methane and aerosols, the contrasting climate effects partially counterbalance each other, and reductions in methane emissions also contribute to improved air quality by reducing global surface ozone. In the long term, the net warming is lower in scenarios assuming air pollution controls combined with strong and sustained methane emission reductions. Our report shows how strategies integrating climate and air quality can achieve multiple benefits and limit trade-offs. And with that, I'll hand over to Alex.
Thank you, Vaishali. The Working Group 1 report has assessed that it is indisputable that human activities are causing climate change, making extreme climate events, including heat waves, heavy rainfall, and droughts, more frequent and severe. In recent years, literature has shown stronger connections between human activities and extreme events through advances in climate event attribution science, which compare distributions of extreme events and extreme conditions in the past with changes projected for the future to understand those human connections. Next slide, please. When we look at this stylized view of the global map, you can see that many regions of the world have trends in which the IPCC assessed confident increases in hot extremes. This is one example of several in which we see that climate change is already affecting every inhabited region across the globe, and we can connect human influence and its contributions to many observed changes in weather and climate extremes. On the next slide, you'll see that there are also changes in trends and attributed extreme events related to heavy precipitation. And on the following slide, you'll see also that we are now connecting human influence directly to changes in drought. Next slide. Next slide, please. So when we look at these observations and others, back one, please. When we look at these observations and others, we see that climate change is already affecting every region on Earth in multiple ways. We also look towards the future and see that the changes we experience will increase with further warming, becoming more widespread and more pronounced with every increment of global warming. In this sense, climate change is not a future tense problem, but one that is affecting us today in every region of the globe. Next slide, please. Working Group 1 has been responsive to policymakers and stakeholders who have asked for more actionable climate information. And in that sense, we have created an inventory of risk-relevant climate change factors that are particular types of climate change known to affect things that we care about, such as ecosystems, agriculture, water resources, and the built environment. We defined this list of climatic impact drivers, with each climatic impact driver being a climate condition that directly affects elements of society or ecosystems. Climatic impact drivers and their changes can lead to positive, negative, or inconsequential outcomes, or some mixture of them, depending on the region and the system in question. When we look across this inventory, we see some related to temperature, some related to precipitation or wind, snow, and ocean conditions. But each type of climate change can affect multiple sectors, and likewise, each sector is affected by multiple types of climate change. Next slide, please. One example of this is shown in the map here as the change in the number of days per year where the NOAA heat index indicates dangerous conditions in a mid-century time period under a high emissions pathway. This NOAA heat index is a combination of extreme temperature and high relative humidity that creates conditions that are dangerous for outdoor workers, such as those in construction or in agriculture. This is one example of how we elaborate on each category of climate information using particular indices and metrics related to tolerance thresholds for these systems. We look at changes in the intensity, frequency, duration, seasonal timing, and spatial extent of these changes and these thresholds so that we can provide a solid foundation in scientific information for resilience planning. Over to Daniel, please.
Thank you, Alex. As he just mentioned, we have responded to the requests of the stakeholders, decision makers, policymakers for information that supports adaptation and climate resilience planning. 1/3 of the assessment report is devoted to regional information. This is an important change in the history of IPCC assessments. The information is also sector specific, and that information has been built on multiple lines of evidence, which, as you know, are based on observational trends, attribution of human influence, projected future changes, and physical understanding. From our point of view, this is what gives us much more confidence in this report's findings. This provides a stronger connection to the regions, and thus it facilitates improved regional assessments. Next slide, please. Today, we want to highlight some of the high-level messages that were included in one of the products of the assessment report, the regional fact sheets. For North and Central America specifically, the assessment suggests, and you can read that on the screen, mean and extreme high temperature expected to increase with larger warming in northern subregions, increases in relative sea level rise, coastal flooding, and erosion along most coasts, except in regions with a strong coastal land uplift, increase in marine heat waves, and finally, strong declines in glaciers, permafrost, and snow cover. We also project the following region-specific changes: temperature increases in northwestern North America and northeastern North America, which will be very large compared to the global average, particularly in the winter. We also project annual precipitation increases in mean and extremes in northwestern North America and northeastern North America. We project increases in drought and fire weather in western North America, central North America, and North Central America. Next slide, please. For Central and South America, our projections point to increases in mean temperature at rates greater than global average, changes in mean precipitation exhibiting dipoles, and by dipoles we mean, please focus on the 3 plots in the second column on the screen. The projected increases in northwestern South America and southeastern South America, walking hand in hand with projected decreases in northeastern South America and southwestern South America. We also project increased coastal flooding in low-lying areas and shoreline retreat, and also increases in marine heat waves. At the region scale, we project decreases in snow and ice, increases in pluvial and river flooding in northwestern South America, expansion of land area subject to increasing drought frequency and severity in southwestern South America, increase in dry days and drought frequency in northern South America and drought duration in northeastern South America, and increased agricultural and ecological drought in South America monsoon region, in the Amazon region, the central South America, and in southeastern South America. Next slide, please. All these projected changes in CIDs are shown in our assessment report in multiple graphical displays for different confidence levels and for different time frames. So we invite you to take a look at the different materials that we have available, specifically the regional fact sheets that we just mentioned. Next slide, please. More importantly, this information is presented in one important product, the new IPCC Working Group Sixth Assessment Report Interactive Atlas, which is a powerful graphic interface for flexible spatial and temporal analysis for much of the observed and projected climate change information, including regional synthesis for climatic impact drivers. There are other online platforms and portals, such as the NASA Sea Level Projection Tool, that allows the users to visualize and download the sea level projection data from the IPCC Sixth Assessment Report, or the Coastal Futures, COFU, a viewer for 21st century projections of climatic impact drivers leading to coastal impacts and risks. Back to you, Catherine.
Thanks, Daniel, and thanks everybody. And just to end, I'm going to highlight that the whole report is available online. It's currently still in its pre-copy edited version, but the final version will be online soon, and you can already access all of the information in the report. So thanks, and back over to the AGU.
Thank you to all of our panelists today. We're now going to open the Q&A part of our session. I'll be moderating. I'd like to remind reporters that if you have a question for the panel, please put it into the Q&A box. Please give your name and your institution, and we'll invite you to open your mic so you can ask your question. Or if you prefer, we'll read your question to the panel. So give the audience a few minutes to get those questions into the Q&A box. That's right, thank you.
We also have a number of additional panelists who are joining us for the Q&A session. Liza has just dropped their information in the chat as well.
Well, while we're waiting then, I think I'd like to invite our additional panelists to go ahead and introduce yourselves. We'll just go one at a time.
Well, since I see my name is at the top of the list, I'm Bill Gutowski. I'm at Iowa State University. I worked in particular on Chapter 10, the Global to Regional chapter in the AR6 Working Group 1 report.
Okay, I will follow. I am Erika Coppola from the International Center of Theoretical Physics in Trieste in Italy. I work on the chapter 12 of the report that has been presented just now for the climatic impact driver framework. I am a regional climate modeler, and in particular, I look at impact and hazard for the water resource sector.
I'll jump in next. My name is Paul Durack. I'm from Lawrence Livermore National Lab over in California, originally an Australian though. I actually worked on Chapter 3, Human Influence on the Climate System, and my research interest is ocean variability and change.
I guess I'll go next. I'm Kim Cobb, Georgia Institute of Technology. I was a lead author on Chapter 1, and my expertise is in El Nino Southern Oscillation paleoclimate.
Great, thank you to you all for coming here today. We have a couple questions, so I'm going to get started. Catherine Snow from KQAD asks, can you comment on the water supplies for urban and agricultural regions based on the drought and rain projections? I guess that's open to the panel, so let you all decide amongst yourselves who would like to start. Anyone from the panel?
All right, I'm going to get started. This is an interesting question and one that we have assessed from region to region. We look in particular at the climatic side of this problem. So the actual allocation of water resources and the impacts of those water allocation and supply challenges are assessed in working group 2. But what we have done is we have looked at different levels of hydrological drought and changes in mean precipitation in different parts of the world. And we have looked in particular at what that means for stream flow and different surface water properties so that we can connect those to needs for agriculture and other municipal and industrial and ecosystem uses for water resources. The assessment, of course, is different for water cycle components in different parts of the world. And within the working group 1 assessment, you will see information about changes in monsoons, changes in large scale modes of variability, and changes in aridity and drought conditions on a seasonal and long-term basis. I'd invite Erica Coppola to see if she can fill anything additional that I missed.
So in particular, as just to complement what Alex said, this information for this, all these indicators relevant for the water cycle and the water availability are assessed for each of the region. So you will find in the report the assessment for pluvial flooding, river flooding, mean precipitation, extreme precipitation. And then you will find all the agricultural and ecological drought, aridity, and the hydrological drought. So this is done for all region, and you can find the specificity of the assessment in the chapter and the summary of the assessment in the technical summary. In particular, there is one table summarizing all these and also the figures of the SPM.
Our next question is from Craig Bettenhausen from Chemical and Engineering News. Can you give us a sense of how much of the global industrial base is located in areas less than, say, 1.5 meters above sea level?
I can take that. So this is something that we did not assess in our report, and it is probably going to be assessed in the Working Group 2 report that is going to come out in early next year, as Catherine mentioned earlier. Right. But we have Alex who can follow up as well and give some more perspective.
Yes, so this is another example of a situation where we look at the climatic side of this question. Overall, the IPCC has taken a risk framework that recognizes that there are climatic hazards, but also the vulnerability and exposure are important components of risk. And this question very much touches on the exposure element of this, of how much industrial base is in an area that would be exposed to a sea level increase. Just to clarify, within Chapter 12 and supported by Chapter 9, which is focused on ocean changes, we look at changes in global mean sea level. We also look at regional relative sea level, as well as coastal flooding and coastal erosion as different components that have slightly different adaptation and risk planning needs. And again, those assessments can be seen on a regional basis in the Chapter 12 and the technical summary and beyond.
Next question is coming from Richard Neal. I presume the projections are based, at least in part, on a number of models. What deference is given to outliers in these models? Go ahead, William.
one of the more recent developments in presenting climate change information is an approach referred to as storylines, where we're not necessarily looking at the probabilistic aspects of climate change, but actually taking physically plausible outcomes that we see from simulations, especially outliers, because if the model that produced it is considered to be physically plausible, then it might be telling us something that perhaps is being missed in other models. And it's not that we want to say that this is what's actually going to happen, but we want to be able to present possible future conditions that may occur that have come out of our simulations.
Erica, did you want to follow up?
Yes, and just to follow up on what William was saying is when we assess the confidence of a direction of change in any of the region, we do consider the literature, but also we report all the spread of the ensemble for all the model. So the outlier are not ruled out, they are presented there. And the assessment is given and the confidence is given high if all the model point to the same direction together with the observed trend and the attribution if viable. So all the information of the model are used even from the outlier.
And follow up from John Dunn.
So one of the things that is new in this report is on the global scale is that we use historical warming to define outliers and constrain projections of future warming.
Do we have any further questions from reporters in the audience? Last questions from reporters? All right, I would like to thank our panelists then for being with us here today. And as we mentioned, you can find in the chat locations where the slides and recording of this session will be located following this session. If you have any questions, please reach us at news@agu.org. Thank you.
And our next press event will be a press briefing on NASA's 2022 Earth Science launches starting at 1 p.m. Central Time. Hope to see you there.